Okay, here we go. First video lesson of many this quadmester. And before we get into it, I just want to reiterate how you take these notes down is completely up to you to figure out what works for you. As I mentioned in my email, and I'm probably going to mention in the orientation teams meeting, some students choose to listen to them once on like 1.5, 2 times playback speed, just listen to it once quickly. Then the second time they listen to it, they stop and pause and copy down the examples. So that's one way. Another way, some students found it beneficial to just listen and pause, copy, play, listen, pause, copy once over. Another possibility is all of the notes are already completed for you as PDFs in the content section underneath each unit. So some students have found it beneficial to either, if you have the ability to, print those notes off in advance and then just listen to it, or have them open on their phone or on another device looking at those completed notes while you listen to me teach it. And those are just some of the ways that some students have chosen to take these notes down. It really is up to you, and there's definitely different variations to that you can do. So right now the challenge for you is to figure out over the next 2 or 3 video lessons what you think is going to work for you. Another way too is maybe possibly even take a look at those completed notes and then copy them down for yourself onto lined paper in advance of the video lesson, and then as you go through, you're referring to your notes as you listen and watch me complete the examples. So again, that's completely up to you. So Unit 1, Rational Expressions. And this first lesson is just dedicated to reviewing factoring strategies that you should have learned in grade 10. Learning goals, you don't ever have to copy these down. That's just what we're going to be doing. And all we are doing is practicing our factoring skills, which is a huge component of this current unit, and to a smaller degree, a component of at least 1, if not 2 units in the near future for you. There are many different types of factoring. I'm going to quickly review all of them. So we're going to start with common factoring. You remember, factoring is the opposite of expanding, and expanding is multiplying. What's the opposite of multiplying? Dividing. So realistically, whenever we factor, especially common factor, you got to be thinking of divide. A common factor, you're looking for the biggest number and or variable that goes into all of the terms. And since we're going to be thinking of divide, I like to right off the bat start with little division symbols underneath all of my terms. So divide, divide, divide. You kind of have to be good at mental math, and if you're not, that's okay. You should have a multiplication chart in front of you then if you're not. What is the biggest number that goes into 2, 4, and 24? Hopefully you're thinking 2, so we're going to do 2, 2, and 2. And then you look at the variables. We got an x cubed, an x squared, and an x. Does x go into all of those? Yes. Does x squared? No. X squared does not go evenly into just the x on the end. X cubed, that does also not go into x. So the biggest power of x that we can take out is 1, which is just x. This term on the bottom that you're dividing by, that is your common factor. So equals, your common factor always goes out front, and you just do the division. 2 divided by 2 is 1, x cubed divided by x. You're going to have to recall your exponent rules from grade 9 and 10. When you divide, you subtract the exponents. 3 minus 1 is 2, leaves you with x squared, and you just keep going along from there. 4 divided by 2, 2. X squared divided by x is x. 24 divided by 2, negative 12. X divided by x, they're gone. I'm not going to bother checking these, but just know on your own, you could easily check these by just distributing that 2x in. And if you factored correctly, you will get the original expression back. B, same thing, common factor. Divide, divide, divide. What is the biggest number that goes evenly into all those numbers? Hopefully you're thinking 3. And then the highest power of x that goes into all of those is just 1, so just a 1x. Now you do divide. Do not forget, whatever you divide by has to go out front. 27 divided by 3, 9x squared. Negative 9 divided by 3, negative 3x. And then negative 12 divided by 3, negative 4. And again, if you don't believe me, you can check it yourself by doing distribution. For any future factoring question that we do, we make a little note here. Always check for a common factor first. So this is the only factoring that you would have to check for every single question. It'll just make life easy on yourself. The next one, a difference of squares. How do you recognize if something is a difference of squares? You're looking for a few different things here. First of all, so these are our look fors. I'm just going to write them in the middle. You're looking for 2 terms. You're looking for a minus sign between them. And 3, you are looking for numbers that have nice square roots, meaning whole numbers. And those apply after you do the common factoring. So we're always going to check for common factor after you've checked it, and if there is one, common factor first, then look for those 3 things. So do I have 2 terms for A? Yes. Is it a minus? Yes. Does 4 and 36 have nice square roots? Yes. However, have we checked for a common factor yet? No. So let's check for a common factor first. What's the biggest number that goes into 4 and 36? 4. So divide everything by 4. And do they both have an x in them? No. So that's our common factor. And that leaves us with x squared minus 9. Now let's check our 3 look fors. 2 terms, check. Minus, check. Does x squared and 9 have a nice square root? Yes, they do. So we know we're doing difference of squares. And difference of squares is really not that bad. 2 sets of brackets, one's plus, one's minus, forever and always. And it doesn't matter what order you do those in. You could do the minus one first, then the plus one. It's really up to you. Now, what's the square root of x squared? Because you can't type that into your calculator. Well, what does square root mean? It means something times itself. What times itself gives you x squared? X. So x and x. And what's the square root of 9? You're going to notice I didn't say square root of negative 9. It's always you never take that negative with the number on the back end. So what's the square root of 9? 3. X plus 3, x minus 3. And again, if you don't believe me, feel free to flex your foiling skills and distributed property, and you should get 4x squared minus 36 back as your original equation. B, is there a common factor? No. Nothing goes into 25 or 16 other than 1. And whenever it's 1, you don't common factor because it's not going to change anything. 2 terms, check. Minus, check. Do they have nice square roots? You're welcome to use your calculator to check. 25, yep. 16, Yep. Y squared, for sure. X squared, 100%. So right off the bat, we can go to this. 1 plus 1 minus. What's the square root of 25? 5. What's the square root of y squared? Well, what times itself is y squared? Y. 5y, 5y. Square root of 16, 4, 4. Square root of x squared, we just learned, or most of you probably already knew, x. So there's difference of squares. And before moving on, just remember, since you're watching this on YouTube, you are more than welcome at any point to pause and go back, catch something I said. If you're like, oh, wait a minute, I don't get that, go back, watch it again. And if you have issues, remember you can just tune in to drop into the Teams meetings. So we are slowly getting more complicated. Simple trinomial. What does trinomial mean? It means there's 3 terms. Simple. It's simple because the leading coefficient, the number out front, is 1. So if I look out front of my x squared, there's just a 1 there. And for b, if I look outside my x squared, it's just a 1. Now you can't just have 3 random terms. So we got to kind of refine that a little bit. You have to have 3 terms, but it's got to be an x squared, an x, and a plain number. Both a and b fit that pattern, so this is a simple trinomial. This ultimately boils down to multiplication tables and you being able to do mental math. If you can't, it doesn't mean that you can't do this. It just means that it's going to take you a little bit longer than somebody else. There's going to be trial and error. If you remember from grade 10 how to factor these, you want 2 numbers. So I'm going to write this in the middle here. You want 2 numbers that multiply to C and add to B. So this is my B, this is my C. I want 2 numbers that multiply to 24. You notice I said positive 24, not negative. The negatives will take care of themselves after. I want 2 numbers that multiply to 24 and add to 5. Most of you, or some of you, could probably do this in your head and you already know the answer. Others that don't know it right away, where do you start? Well, let's start with multiples of 24. And if you want, you can write them off to the side. So maybe we'll write them off to the side. And I'm just going to do this first question this kind of long way just to show everybody what you could do. So 24 and 1. That definitely multiplies 24. I don't think I'm going to be able to get 5 out of those. If I do 24 plus 1 or 24 minus 1, not going to work. All right. Let's try 12 and 2. Multiplies to 24. I don't see how I could get positive 5 out of those, though. 3 and 8, maybe. Multiplies to 24. And anyone see how you could get 5 out of those? 8 plus 3 is 11, but what about 8 minus 3? Well, 8 minus 3, that's definitely 5, and 8 times negative 3, negative 24. Like I said, the negatives are going to take care of themselves. Because sometimes thinking of numbers that multiply to a negative number can throw some people for a loop. So what do you do with those now that you figured it out? Well, for a simple trinomial, 2 sets of brackets, x is going to go first for both. The numbers we just came up with that gave us the right combination, you're just going to fill in here. X plus 8, x minus 3. Simple as that. Another way to help organize your thoughts with these is what's called the box method. And it's kind of overkill for a simple trinomial, but it could help you later on. So I'm just going to make this little T-chart box looking thing. It's not really a box, I didn't fill it in, but whatever. And basically you want to have two numbers that multiply to A, two numbers that multiply to C, and you want them to add to the B term. My A is just 1. What two numbers multiply to 1? Well, obviously 1 and 1. 24. Now we could have gone through all of the trial and error that we did already. 24 and 1, 12 and 2, 8 and 3. We'll go through the same thing, but we'll cut to the chase here. I know that 8 times 3 is 24. And I know that I have to get 5. So once you've established, well, that's got to be negative. And then you'd be like, 1 times 8 is 8. 1 times negative 3 is negative 3. That equals 5. Makes me happy. We got what we're supposed to. We got our B term. Now, how you put that together, your factors are along the diagonals, which again would be 1x plus 8, 1x minus 3. This is just another way of organizing your thoughts or organizing your trial and error. Like I said, I'm just going to do that long way for A. For B, we're just going to cut to the chase. And if mental math isn't your thing, that's perfectly A-okay. You stick to trial and error. So I want two numbers that multiply to 12 and add to negative 1. Well, I know for sure that's going to be x and x. And hopefully you are thinking that it involves a 3 and a 4. I got to get negative 1, which means the larger number is going to be negative. So negative 4, positive 3. Remember, you can always double check these by flexing your FOIL skills and make sure you get the original equation back or expression. So hopefully there's no questions. Again, remember, I'm here to help you. Email me, message me in Asia, whatever, pop into the Teams meetings. This should be review of grade 10, but I know some of you are coming from different backgrounds and different times taking the grade 10 course. So there will be lots of time to practice later after this lesson. A non-simple trinomial. So there's 3 different ways you can do this. And we're going to start with the box method, which I kind of already showed you. How do you know this? Well, first of all, trinomial, right? So we got 3 terms. How do you know it's non-simple? Well, it's got ax squared plus bx plus c, but your a value is not 1. So if I look at my a value for a, it's actually 3. And for b, it's actually 6. Now you should always look for a common factor first. There are no common factors for a or b. So like I said, for a non-simple trinomial, there are 3 ways. I'm never going to force you to do it a certain way. I'm going to show you this way plus 2 other ways, and then it's for you to practice and pick one that you like. So for this first part, I'm going to stick with box. So we're going to make that. I want 2 numbers that multiply. You don't have to write these in your solutions, but I'm going to just for now. I want 2 numbers that multiply to the a, which in this case is 3. And that's pretty simple. There's only 2 numbers that multiply to 3, 2 whole numbers that is, 1 and 3. And made this one really easy for you guys. The only 2 numbers that multiply to c, which in this case is 1, right? This is a, b, and c. The only 2 numbers that multiply to 1 are 1 and 1. And if you multiply across, 1 times 1 is 1. 3 times 1 is 3. I got to get 4, right? Because b is 4, and 1 plus 3 is 4. So I don't I don't have to change any of the signs. There are my factors, 3x plus 1 and x plus 1. Now, I know some teachers, when they do this, depending who you have, they, instead of multiplying across, they multiply on an angle and make the straight across the factors. It doesn't matter, 6 of one, half a dozen of the other. Either multiply across and adjust to make the diagonals your factors, or multiply along the diagonal and make the straight across your factors. And if that completely blew your mind, your teacher, you're fine with how I just did it. Don't even worry about what I just said. B, I want two numbers that multiply to A, which is, there's A, B, and C. And you got to get B here, which is -1. So the first one is really easy. This one I'm going to show you the actual trial and error process. So let's say two numbers multiply to 6, 6 and 1, let's say. Two numbers that multiply to 12, 12 and 1. 6 times 12, 72. 1 times 1 is 1. There's no way I'm getting -1 out of that. Now, just because you try 12 and 1 doesn't mean that the reverse doesn't work, or the converse, which would be 1 and 12. 6 times 1 is 6. 1 times 12 is 12. No way I'm getting -1 out of those either. Now, if you know the answer already, that's awesome. For the sake of everybody else, I'm going to go through all of these, or at least some of the trial and error. Okay, so we know 12 and 1 doesn't work. Let's try 6 and 2. 6 times 6, 36. 1 times 2, 2. Definitely not getting -1. Let's try 2 and 6. That's 12 and 6. Nope. So you can see how this can be trial and error. And this is why I personally don't like the box method. Okay, let's try 3 and 4. 18, 4, nope. Maybe I'll save myself some erasing here. I'll just scratch those out. Scratch those out. 4 and 3, that's 24 and 3, no. So I've tried all the possible combinations of 12 on the back end. So what that means is 6 and 1 are probably not the right combination. So what other two numbers multiply to 6? 3 and 2, let's say. Now, most of you see me just do it the first time with all the trial and error. You probably get it. I'm just going to give you the answer. So 3 times 3 is 9. 2 times 4 is 8. We're close. I got to get -1, which means that's got to be negative. And that for sure is -1. And if that right there is negative, that right there is negative. And then just double check, -3 times 4, is that -12? Sure is. So my factors are along the diagonals. And it doesn't matter which one you put first or second. 3x plus 4 and 2x minus 3. So there is box method. Still doing non-simple trinomials. A is not 1, no common factoring. Now we're going to do decomposition. Now decomposition, I like to make a little X here. I like decomposition because it eliminates some of the trial and error, but you still kind of have to be good at multiplying in your head. So here's what you do. I'm going to make this little, I may even just do it off to the side here. I'm going to make this little x. And I'm going to write times AC. And I'm going to write adds to B. So I want two numbers that multiply to AC and add to B. So let's multiply A times C. And again, there's A, there's B, there's C. 3 times negative 3 is negative 9. It's got to add to 8. What two numbers multiply to negative 9 and add to 8? Hopefully, you are thinking, I'll change the color here. Hopefully, you're thinking 9 and negative 1. That definitely works. 9 times negative 1 is negative 9. 9 minus 1, 8. Perfect. So here's the decomposition part. We're going to use these two things here. So you start out, you rewrite this term, and you're going to decompose. Decompose means break up. We're going to decompose that into those two numbers. So plus 9x minus 1x, and then you rewrite the C term, negative 3. Then from there, you common factor in groups of 2. So I'm going to look at just these first two. What can I common factor out of just those first two terms? 3x. Which leaves me with x plus 3. Then you're going to common factor the next two terms. And all that I can take out of that is negative 1. Which leaves me with x plus 3. Now you should notice something. If you've done decomposition correctly, you should notice something at this step. And what you notice, if you stare long enough at it, this and this should always be the same thing. That's how you know you've done decomp correctly. Then you're basically doing another common factor step. What's common to both of those things? What's common to this and common to that? Well, x plus 3. And if you were to common factor that out of the expression, you would be left with 3x minus 1. And we have successfully factored that. Let's try this method again. So I was going to make this little x. I want two numbers that multiply to AC and add to B. A times C, remember A, B, C is negative 30. B is 1. What are two numbers that multiply to negative 30 and add to 1? Hopefully you're thinking 6 and negative 5. I'm going to use those two numbers. So again, rewrite this. We're going to decompose that middle term. 6x minus 5x minus 15. Common factor in groups of 2. I can take out a 2x, which leaves me with x plus 3. Next group of 2, take out the negative 5, x plus 3. We know I've done my work right because that's the same as that, which means you're left over with x plus 3 and 2x minus 5. Hopefully that's okay for decomposition. Like I said, the only way I'm going to keep harping this, the only way you're going to get better at these is by practice, practice, practice. Math is a skill. To get better at skills, practice makes perfect. So you got to practice all of these before you decide whether you like them or not. And I would say, to be honest, you should practice each one of these methods at least 3 times. And after the third time, if you're like, I don't like it, then move to one of the other ones. If after the third time you're like, I don't mind it, then stick to that one. Or if you have a couple of preferences, then you could do them a couple of different ways. Our third and final way. This is actually my own factoring style. I came up with it just looking at patterns. Just kind of dawned on me maybe about 6 or 7 years ago. Now I do see that there's some people out there like some YouTubers that kind of came up with the same thing, but when I did start doing this 6, 7 years ago, I didn't see anybody else do it this way. Not to say that they didn't already think of it, but for now I'm just going to call it Sulio style. But lots of other people, way smarter than me, probably come up with the same way. And I think even Nancy Pye, YouTube, she does factoring like this too for a non-simple trinomial. And what we're going to do is we're going to kind of borrow. That's why I had you last example make that x, because this kind of borrows that same idea. So two numbers and multiply to AC and add to B. And there's A, there's B, there's C. 5 times -4, -20, and my B value is -19. So what two numbers multiply to -20 and add to -19? And just for simplicity, I kept these two examples easier, but it does work for any of them. Well, -20 and 1 definitely multiplies to -20, definitely adds -19. Now the key to this is where it's a little bit different than decomposition. It's just number patterning. The key to this is the A value. So I'm going to circle it. And what you do is you take these numbers you came up with and you divide by the A value. What's negative, and what you want to do is reduce the fraction. So what's -20 over 5? What does that reduce to? Well, that reduces to -4 over 1. And 1 over 5, that doesn't reduce to anything, it is 1 over 5. Now how this gives you the actual answer is right from here is, whatever the denominator is, the bottom of the fraction, that is your x term. So that's an x and that's an x. And what you do is you take this with this to make your factor. 1x minus 4, 5x plus 1. Now, if you don't believe me, you can double check it, FOIL it, but there is a factored Sulio style. Let's try it again. Multiplies AC, adds to B. 6 times -4 is -24. My B value is -23. Like I said, I kept these ones easy just to show you and make it so it's not reliant on your ability to multiply in your head, which unfortunately a lot of factoring is. -24 and 1. Those definitely multiply to -24, add to -23. And the key to this is the A value. And you divide by A and reduce. So that reduces to -4 over 1. And remember, this gives you the x. So 1x minus 4 and 6x plus 1. And again, I can't stress this enough. I kept these ones easy. It's not always going to be like 20 and 1 and 24 and 1. They're going to be different numbers. But I wanted to mainly focus on the process for you as opposed to your ability to multiply. Any questions? Raise your hand. No questions? Great. Fantastic. Good. You guys are awesome. So your seat work, or homework, I guess it would be. You are going to complete the handout, which is hyperlinked in D2L right beside this lesson. There are a lot of questions there. I'm not going to assign you specific ones. Again, you should practice what you're not good at. So practice some if you got it, skip the rest, go to the next section. Practice some, skip, practice some, skip. Whatever you need to do to regulate your own learning and therefore your own success. At bare minimum, like I said, those last 3 styles, box method, decomposition, Sulio style, I would go to the non-simple trinomials and I would practice them 3 times each at bare minimum. And from there, decide which one you like the best. And from there on out, practice that one forevermore. But like I said, factoring is a large portion of this unit. And you want to get that skill down as best you can. Otherwise, doesn't mean it's impossible. It just means it's going to take you significantly longer to complete the test than somebody else. And your tests are timed, so you don't have unlimited time to figure that out. So that's it. You survived your first lesson, and you will hear me again very soon during video lesson number 2.